Hello and welcome. This is a very quick rendition of binary logistic regressions from Chapter 8 in the Fields book. I will definitely not cover everything that's here. Please don't act like I am, but it's a real quick rundown. So first off, we need to load in our data. So I'm going to load in data, which I'll call EL data. This is a really weird data set if you want to look into the book and find out what's going on. My daughter's calling to me. Alright, quick summary of that. Gives us these. Now, these are not in the order we want them to be in. This says a 0 is cured and a 1 is not cured. A 0 is intervention and 1, that's just not the way we read things. So I'm going to re-level both of those so that they're in an order that makes sense. And then run the summary again. Now not cured is the top and no treatment is the bottom. It's not that we couldn't have interpreted it before, it's just prone to miscommunication and confusion. Make zeros no's and ones yeses. Alright, so our first model is named EL Model 1, General Linear Model. We are predicting cured based off of the intervention, and that is all. Our Model 2 is trying to predict it based off of intervention and duration. We then are interested in seeing the data for these two models. So for our first model, we have a significant value on the intervention. Good to go, but we don't get a p-value overall here. We can talk about that later, but a takeaway is if your value is significant, you're good to go. Down here we have two, intervention and duration. Duration is not significant. We also have this little AIC number, which I'm going to ignore right now, but later in life you may find out about. It really is just to let you know if you're comparing and adding variables is worth it or not. You'd hope to see a significant difference between those two if adding the value is worth it. Okay. This is a pile of code to create a pseudo R-squared. There are people who think that there's absolutely no reason to run these, but I told you about them, so I'm going to show you really quickly. So if we want to run our R-squareds on the model that was significant, we have somewhere between 6 and 11% of the variation we think is explained by the variable intervention. Now, that's pretty much where we want to go. If we would like, we can also ANOVA between those two models. We can make a model which is a summary of those. Sorry. Let's call this thing check. Let's summarize check. And that'll give us a little bit of information, but not a ton. But we can look here and say there wasn't any deviance between the two, so we can pretty confidently say the second model isn't better than the first. And remember, it didn't have a significant variable, so you wouldn't want to use it anyway. If we want to figure out what's going on from this, we can run a summary. We have a p-value which is significant. We have an R-square, and we don't really. Oh, sorry, was that the wrong model? Sorry, that was the EL. That's the last model. Don't listen to me there. Back up. Okay, better. Okay. So again, we don't see a p-value here, and we have just this intervention variable. So we're going to say intervention occurs. We're increasing our odds by this amount. Our estimate stayed here. And that's basically how we interpret this, just to say we have a positive relationship between intervention and curing. That's pretty much all I want to say about that. Have a good one.